Hey everyone, I'm Joe, a junior computer science student and a cybersecurity enthusiast, always hungry for a deep understanding of things I work with and exploit. I come from a different background, which is network pen testing and AV evasion techniques and AD attacks, antivirus and Active Directory. It's 2 months ago in my journey of getting into web bug bounty hunting world, and I learned a lot from write-ups and noticed that most of the people don't hunt on SQL injection manually, except for a few people that are experts that do those bypasses and obfuscation techniques. So today I'm going to put you on the road of understanding how you should think when testing manually for SQL injection. And if you understand every single word in this write-up, all you need is just sharpen your skills at obfuscation and encoding bypass techniques to bypass WAFs. By the time you could increase your bypass skills from an advanced write-up and bypass complex WAF write-ups. But for today, you need to know how to think when you need to test for it manually. Since the target is private, let's call it bug4u.com. Let's jump into the SQL injection without wasting any time. For the sake of your valuable time, if you are a SQL injection hunter professional who comes here looking for payloads that worked with me, go and read from the second bug until the fourth bug and leave the first bug, because I explained in it a very useful principle details to those that are not hunting manual at all. So yeah, it's trivial if you're a skillful SQL injection manual hunter. The first bug. Here's an endpoint that was used for downloading audio of some music, and we can see a get endpoint. We have what seems to be an identifier there, or at least a number, and a song seems to be downloaded because we do have quite a big content length, and we seem to have what is known as binaries there. But think with me, what would happen if we put in a single quote in that number? Look at that. We only have 306 bytes coming back now. The result changed completely. There's no audio coming back within the response. So yeah, that will be your first hit. Putting a single quote or double quote at the parameters you faced and observe the response if there are any tiny change. It will be definitely vulnerable to SQL injection because this will indicate that the backend didn't sanitize the inputs properly. Now, a little side note here, I don't fully agree with this. It could also be just that there's some internal error that's not SQL injection, but he is right, this might point to SQL injection. And literally, I mean it, tiny change, but in some cases, there's a target that's configured manually when it receives those dangerous characters. It will give you back a 200 OK, but it's just a custom page telling you that the resource is not found on the server or something like that. It didn't mean this change. I mean this change within the same responses endpoint, not different responses come from another endpoint. This includes changing within the responses length, responses contact, and sometimes the responses time. Since there are some cases the backend would handle the query in a different way, that makes it take much more time if there's an error in the SQL syntax or in the input is a very large string or number. So yeah, just detect any abnormal behavior in the response and you will go from here as I explain in a couple of minutes here with you. Now, this is just something that I always want to say. Before you can observe abnormal behavior, you need to know what normal behavior is. And you can only know what normal behavior is if you use your application to its fullest extent and if you don't hesitate to use it until you're bored, basically, because if you're bored, you're familiar with the application and it'll be much easier to detect this abnormal behavior. Nice. Until this point, we know that injecting a single quote will break the SQL syntax and result in not giving us the audio in response. So now we observe that we are inside the SQL statement that is closed with a single quote. But what if we put and 1 equals 1 there? So besides the number ID of the audio, the comment, the rest. So the query is going to look something like this. You have 316 and 1 equals 1 single quote and then some endings of the SQL string. Still doesn't work. So in this case, we can see it didn't work. But what about the hash sign, our amazing hacker asks? Same thing. So the hash sign still gives an issue. But what if we just try to inject and 1 equals 1 and didn't comment anything after the query? So he's only just trying to get a result that returns everything. In this case, we can see that when he does that, we do have some values returning. If he does 1 equals 2, we don't have any values returning. So we can clearly see that he can influence this query. So now we know that from here we can continue the exploitation phase with a Boolean-based SQL injection without any need to break the SQL statement or close quotes. Just think deeply what you can do to achieve your objective, because in your situation might be a must to close a single quote to work with you and getting back the same response from the server. It might be a must to URL encode the hash character hashtag like %23, or even double decoded like %25, %23, and he means encode, of course, and %25 there is your percent sign. So if you decode this, you would get %23, which is your hashtag character, along with a single quote or double quote. We are here to think what is the situation and injection capabilities we have to craft our exploit payload. Because one day you will face a situation when you're blocked by a WAF, but you can inject things like and, or, from, select, update, insert, sleep, single quote, double quote, etc. Someday you could inject those by themselves, but when combining them with an exploitation payload, you could end up with a 403 forbidden by Mr. WAF. You can inject those fine at any place without getting blocked, and you might face a situation when you're getting blocked if you put the parentheses, but with unicoding one of them, you'll be able to bypass this again without any blocking. So basically your first objective is to try and identify what you can inject and where you can inject it. Which location in the SQL query are you injecting into? And here you should have a far imagination about the query inserted at the backend and assuming lots of ideas, like see the parameter in the name and observe what the developer could think when he was implementing that parameter with this name. Is he trying to retrieve audios with some sort of other parameters that he combined them with the union query? Or is he just trying to save your update results on the database with an insert query? Once you deeply understand your situation and what characters work with you and what don't, you crossed half the road now. Because from my point of view, the rest of the half will be bypassing those techniques. Now, getting to this point, the first thing you need to do is extract the database version from the database to decide what your next steps are. Because, of course, every DBMS, database management system, has a different way of interacting with it. So we are going to retrieve the information scheme payload that is responsible for fetching the database names, and it should look like the following. My methodology here of getting the database version is by a bunch of trials. What you can do is basically fuzz on the database version with a bunch of each technique for every type of database. Okay, fine, now we know our injection point and how to inject, and if it needs any obfuscation or not. Until here, we could try and dump the database version with the following techniques. For Oracle, you would do a select banner from vversion. From Microsoft SQL Server, you would do select add version. From never mind, select version. And from MySQL, select add version PostgreSQL. Freaking hell. Now you should try it with the substring method. Now, which one of these you try is dependent on which database management system you have behind you, of course. You're gonna have to try all of them to figure out what you're dealing with, and you might have to obfuscate certain things. Now you should try it with the substring method. First, understand the substring method. With substring, you can extract part of a string from a specific offset with a specific length. Each of the following expressions will return the string yo. So you can see here that for each of these different database versions, database management systems, we are using the substring command with the bug for uString in it, and we take from position 5 maximum 2 characters. So that will only return yo. 5 is the starting position, 2 is the length. Now our crafted payload will work with the following. For MySQL, we have a question mark, lugu equals, and then the number. And then we have those pluses. Those are just URL encodings for a space. So we have and select substring at version 11. So he's trying to basically select the substring from the version from position 1 with the length of 1. And if that is version 4, then he's going to return something. So we'll try to fuzz the first characters of the database version here and these different payloads, as you can see with the intruder tab, and one of them should work. where we are going to see what is the first number of the version, and we're going to try to compare that with something from the intruder, just numbers that we're going to generate, and we're going to see if any of those match the first character of the version of the database. As a payload type, we use a brute forcer with a character set of A, B, C all the way up until 0 and 9, with a min length and a max length of 1. Very useful information there. Now we're going to start the attack, and as we can see, 1 did return a full length, and that was in this case version 5 or payload 5. Nice, observe that it works with us with the select substring at version, which indicates that it's a MySQL or or MS Microsoft SQL database, and the first character of the database version is 5. Now we need to repeat the same process to fuzz the next character, but with a tiny change in the payload. Keeping close attention below here on the substring, we're fuzzing on the second character here, not the first one. The first 2 characters starting from the first character as described above. So here you can see we are going to fuzz for 2 characters because now we know that the first one is 5, but what is the second number in that sequence? And with the same attack we can find out that it's a period, a dot. So it's going to version 5 point God knows what. Now we know the first 2 characters of the database versions, and all we need to do is repeat this until we get the full database version. Until this point, you can report immediately before anyone uses SQL Map, since SQL Map sends lots of known traffic known by most WAFs, and SQL Map could give you an error even if it's the endpoint vulnerable, but the WAF blocks you after some malicious requests. And you know what? I have a friend from India who reported SQL injection from SQL Map and literally was about to get 6,000 bounty, but the trigger told him that the issue was known internally by the team and working on it. 100% blue team here, and had seen all of this weird SQL Map traffic and passed it on to the pen testers and checked it and find that it's actually vulnerable. This is a big tip. If you use automated vulnerability scanners, they are very loud and you might miss out on your bounty because it's already been reported internally due to your heavy traffic that's being generated. So yeah, that's why I like manual tests, to keep my traffic as low as possible, plus learning more and more obfuscation and bypass techniques. Because let's be realistic, if it's that easy for everyone can do it and report with SQL Map, that's why companies pay thousands of dollars for SQL injection vulnerabilities. You wouldn't get this with SQL Map, buddy. You will get it by understanding how the query works and where you can inject and what malicious characters you can inject. And from here you could obfuscate and bypass the WAF. Fortunately, in my case, there are no WAFs or bypasses or obfuscation techniques. An important caveat that we need to make here as well, of course, is that you need to test the parameters which are known to have some kind of SQL statement in the backend. I mean, there's no point in testing a parameter of which you're 100% sure that it doesn't do any SQL statements, or at least you should test them as the very last. The ones that do SQL statements are the most vulnerable. Those should be inspected first. Fine. The important tip here is to think of your capabilities of infection and where you can inject those and how you can inject them. URL encoded or Unicode encoded, or put along with the payload comment like /**/ or even encode just 1 character in the payload. Let's get back into my bug. You can report it as database version, of course, but if you need to show more impact, let's dump the database names. Now that we know at version, the one that worked with us by observing from the above payload, that it is the one that worked from the 3 above payloads, let's get into documentation to check how to retrieve database names from the information scheme. We can check the documentation, and first you need to understand that this query in MySQL select 1 from information schema.schemata, where schema name like %, and then your single quote, information schema.schemata is the system catalog table where the database metadata is stored. Schema name is the column in this table that stores the database names, and like %, is the condition that filters the database names, returning only those that start with the letter A. You can also have %, of course, where you return everything. So overall, this query will return 1 if there is a database that starts with the A character. You could also select the name itself, of course, since you know that it's the schemata. It's this information scheme.schemata, of course, or schema name. You could also select that. So select schema name from information schema.schemata, where in schema name like 8%. That's also a possibility. But here we have chosen for this tag factor, and let's jump into the execution, where we can see in this case that we have something returning 306 bytes. So now it should fuzz on that characters that are using the same SQL statement to get the right first character of the database names that are inside the information schema table. Now, why is he doing it like this, you think? Because this is a blind SQL injection. So here, it wouldn't make sense to select that schema name because you couldn't see it. They're just returning a 200 page, like he said before, where it's only returning 200 okay. Even if there's like an error in the backend. So here we need to know if something exists with the letter A, if something exists with the letter B. So he's going to try to fuzz that. He's going to try to fuzz with the letter A, B, C, D, and that's going to be his first letter. In the results, we can see an I returning, and we can see a K returning. So we know that we have two tables starting with I and K at the very least, and we can put the same thing back. If we go back to the repeater, we can start fuzzing for the second character, and you can fuzz that way for the entire database name. So until this point, it's a very detailed proof of concept of having the ability to dump all the database names. You can report it now, buddy. However, if you're really interested in extracting the table names, it will be something like this. Select the table name from information scheme.tables, where table schema equals your database name. Both MySQL and PostgreSQL support the use of information schema catalog to query metadata about their tables, schemas, and databases. The query I provided is a common way to retrieve table names from specific databases, regardless of whether your target is using MySQL or PostgreSQL. One, of course, you will combine it with a Boolean-based and 1 equals 1 like this. This final payload will check if there's a table name in the database that starts with the letter W, and the same process to continue dumping the whole table name as described earlier using the interior tab. And also if you need to dump columns, so refer to the MySQL docs for more information about dumping column names. So it's the same idea, and you can of course dump data as well like this. If you know the columns, if you know what fields they have, you can know what data is in there. It will take a lot of time, but this is definitely doable. The first report is done. As for the second bug, here it's another endpoint that is responsible for searching for items in the store from the database. Fortunately, the parameter of its search here is not sanitized properly at the backend. So we can see O bug for you and %URL equals. If we go looking fine, let's put our magic quote in the O, and we can see warning MySQL fetch array expects given parameter 1 to be etc. As you see, it's vulnerable easily. Not like the first one that was Boolean based, and here if you put any single quote you will see an error. So this one is not blind SQL injection. Okay, fine, let's fire out some payloads. Guess which payload worked for me? This one. Bug for you, single quote, and select one from select sleep 10. Now this is what is known as basically you're going to try to make the database have a little bit of a delay, basically. The problem here is that this is very susceptible to one call just being slower one time. Because if your one call is slower than 10 seconds one time, but it was just a hiccup, you might think that you have it, but you might not. So I would always recommend getting a sleep of 30, because it's often hard to get like a 30-second delay, and also repeating this at least a few times so you know it wasn't a temporary hiccup. This is blocked by, I think, some firewall rules, not a WAF at all, because the bypass I did is URL encoded in some characters on it with some comments like the /, &, /. I didn't need Unicode encode at all. After almost an hour of being detected, here's the final payload. So we can see that we have quite a few bypasses here. We have, for example, the S from select being encoded by a %53. We have a from with a small letter, a capital letter, small letter. We have SE in the back with a %4 to represent a L, for C to represent a L. You can see that there's quite a few bypasses here that are applicable. Good job there. Just URL encode some characters and put some in comments, easy. And of course, you cannot forget those camel cases, that's important as well. In most cases, this payload will be blocked by modern WAFs now in 2023, but yeah, it's an awesome one. I see another researcher did it in 2020 and it worked with him and he got a $2,200 bounty. So it depends on your target and the firewall rules implemented besides the WAF. So add it to your word lists. It worked with me a lot of times when finding an old endpoint with the Wayback URLs tool. Most of the time the developers ignoring removing the useless PHP files or the old P files from the servers, and you can literally find those endpoints with its parameters on a plate of gold with the Wayback URLs tool. For me, I do the -dates switch to check the time of all the files and go for old dates. What I also do is I just go to Wayback Machine myself sometimes and I just go and look up the website, and there's a handy dandy little sitemap. It's literally a circle and it starts with your root domain and then it goes up directories, which cuts it into smaller bits of the circle. It's really interesting. I would go for it and have a check if I were you. It works with me a lot of times when finding old endpoints with Wayback URL tools. Most of the time the developers ignoring the useless PHP files or the old files from the server, and you can literally find those endpoints with its parameters. So as you can see, we have an echo bug4u.com with the Wayback URLs -dates parameter there. This landed me with very old endpoints that the developers forgot to remove from the server and are still accessible to the public and vulnerable. However, here's the proof of concept. And as we can see, when we give this or when we request this data, we can see that it took quite a long time for it to load. Forced the database server to sleep for 3 seconds and 8 seconds. The third bug here, it's another endpoint that is responsible for retrieving audio information about some attributes related to the audio. Fortunately, the parameter of the audio here is not sanitized properly at the backend. Here I really want to show you how powerful to observe any changing happens in the response, as I said earlier in the tips of the first bug. As we can see, we have a normal audio endpoint, which is about 17,000 bytes. If we enter a single quote, we get about 15,000 bytes. Did you see that? No, not the response's length, I mean the response's body. Let's go back to it. So if we compare the responses right here, we can see a pretty normal body, or at least what seems to be a normal body, but pay close attention to the responses at the two pictures. It looks the same in the two cases, and it's the point here that a lot of researchers move on when they see no difference in the repeater tab or even on the responses of their own browser. But in the reality here, that this endpoint just retrieves the audio information and HTML format response in a small size at the end of the page that is stored in the database and just prints its name and some other attributes related to the audio, like name of the file, author of the audio, date of the uploaded audio, etc. On the HTML content, so yeah, when injecting a single quote, it seems like the developer handles the situation at the backend. When injecting any malicious character, he exits from the query at all and didn't execute it and didn't give back any information about that audio. That's my assumption here about why the responses length decreased to almost 2,500 bytes. So yeah, that's how you need to think about any functionality you are testing. The difference here actually is in the response's body, but below at the very end of the HTML response, not obviously in your screen at the beginning. You should scroll down to see the whole response. That's why I told you from the very beginning at the tips in the first bug that to observe any tiny change, and I literally meant it. Differences in response length, response content, responses delay time. If you wonder about the response's content, I want to surprise you that in some situations when you inject a single quote or a double quote as described, you would find that the servers responds with the same response length but with a completely different body. I hope that these tips find you well on your side of the screen. Now back to my bug. Now we know that is vulnerable since there's a change in the response length. So let's go. The final payload worked with me, and after lots of payloads and concatenation stuff, we have if now like sysdate sleep 60. Again, we're trying to make the database sleep, and we are able to make it sleep for 6 and 10 seconds. I tried a lot of obfuscation techniques to dump anything from the database, and I couldn't. So it's to one of my favorite Indian friends who collabed with me, making the impact a little bit higher. He also couldn't dump anything, even the banner. And I'm not Indian, by the way, but I have a lot of friends from India in this field. Shout out to India. Hey, what's up, bye? Very friendly and hardworking people. So yeah, I reported it as it is. Time-based SQL injection. As for the fourth bug, here's another endpoint that's responsible for retrieving some information related to the author of the audio uploaded to the database. And as always, the first hit is injecting a single quote or double quote and observing any changes in the response. We can see that in the first one we have a body of 13,000 bytes, and in the second screenshots we only have 1,095 bytes left. The error here in the picture also reveals you have an error in the SQL syntax. Check the manual that corresponds to your MariaDB server version for the right version near line 708. So we already know that it's MariaDB, and we can see select lang ID from CMS object where object ID is. We can see the whole query there, which is freaking awesome. So the error here in the picture reveals the column name, lang ID, the table name, CMS objects, and the object ID, which is another column name, also from the database. All of this should be not retrieved like this. So I was thinking of error-based SQL injection, and here are my results. My methodology when I face an error-based SQL injection is the first thing I try to inject is yes, you can see on screen, a single quote, pipe, select, single quote, close parentheses, pipe, single quote. Both of the pipes here are used for concatenating the strings and the SQL syntax. Google it if you don't know how it works. If it gives me a 200 OK, this will mean that it's the SQL, my SQL or my MS SQL. But if it gives me an error in the response, this will indicate that it's not Microsoft SQL or MySQL. So based on my experience, this is a valid query in MS SQL and MySQL, but not in Oracle, since Oracle requires the clause from, and it's not exceptional. Summary of the tip: if we don't write the from clause within the Oracle database, we'll get an error. And the second step is to inject select single quote from dual. And this gives me a 200 OK. It means it's an Oracle database. So what is that dual word in Oracle SQL? The dual table is a one row, one column table that is often used when you need to perform calculations or retrieve single values without referencing an actual table. It serves as a convenient way to evaluate expressions, functions, or subqueries. You typically use dual in any case where you want to select or manipulate data that doesn't come from a table, such as the result or a function or an expression. Example, select 1 plus 2 from dual. So yeah, basically, if it gives the 200 OK in that response, I will know that it's Oracle. And the third step is to inject select single quote from bug for you. Since that bug for you string here makes no sense from the perspective of the database, this should retrieve an error. Just want to ensure that I'm working fine with a deep understanding of the case I work on. The above injected payloads, sometimes I encode some multiple encoded formats on them, or added some comments between the whole payload, like star slash asterisk slash comment. Till this point, I disclosed all of my thoughts and ideas while testing, so let's go back to the bug, where we inject this, giving us a 200 OK, which indicates it's an Oracle database, and it's indicated that it's a completely different response length. And I got confused. Even till now, I still don't get why the server responds with a different length. So I'm not really ninja at error-based, and hope if anyone professional at it to ping me on Twitter for a collab next time if you like. But for it landed me with time-based and worked fine and reported it. Until here I got confused with the above trials of the payloads because the response's length changed. So I shut down my mind from error-based and I was thinking about time-based to report it fast. After a bunch of trials with time-based, here's the payload that worked with me. So you can see here that we have the select sleep, which is going to be a time-based SQL injection. It tries to make the database server pause for 12 seconds if the condition 1337 equals 1337 is true, which it is, of course. Then we have the OR. This is used to combine the conditions. Then we have that 1337 equals bug for you. This part is just to evaluate 1337 with the bug for you string. And of course, in this case, it will return false. However, since there is an AND and an OR operator, the AND that are from the left would evaluate first before the OR. So yeah, adding the OR part here at the very end of the payload looks useless. In some cases, this trivial technique of adding the OR operation with wrong evaluations, like we had before, would give you the ability to bypass the firewall rules sometimes. Or even you can make 1 equals 2 or just any wrong condition with the OR operator along with your payload. And for sure, sometimes you will need a proper encoding and a little bit of obfuscation on it to pass. So yeah, ended up with a time-based SQL, not error-based. We are done here. Really hope you liked how to think when testing for SQL injection manually. Based on my experience, if you got all of my above ideas in the 4 bugs, you'll just need to read more and more write-ups about bypassing WAFs and obfuscation techniques. Thank you so much. Thank you very, very much, Bug for You. Thank you so much, Youssef, I think is your name. I really, really appreciate this write-up. I'm definitely going to give it a clap because this is well deserved. You are awesome. I think you have a very bright future ahead of you. I'm not gonna lie. This is something that is not easy to find, and you might say, oh, this was easy, just a little bit of manual exploration. No, it's not. You had to combine various techniques of obfuscation and coding, but also finding endpoints, which isn't an easy thing to accomplish. Knowledge of databases had to be involved. But if you follow all of the wisdom that is in this thread, in this awesome Medium article, I am sure that you also will at least have much more success than you currently are having with SQL injection. Awesome guide, Youssef, really well done. You'll get far, amazing hacker. Thanks everybody so much for watching. Now go to the article below, go give this amazing hacker a clap at the very least. Go to his Twitter, go follow him there, and go to his GitHub, give him a little bit of a star. Thank you so much, amazing hackers. I will see you in the next one.